So here you see the difference after rescaling, and you also see here now that the standoff is totally out of the whole thing, floating directly apart after the resizing, which of course takes quite a long time. So now it's 110 diameter, but of course now I have to make some changes in the design to make sure that the standoff is somehow to be able to connect it. And I probably will do it just by a 3D printed fork or something like that I put on top of it, so that it can stay small. And here this just a kind of fork that goes around the standoff and just connects it, because I will be using the standoffs that are already there. So probably easier to do it like that, because also the outer plate will be around it. And of course, when I will be driving it, it will not use this whole middle part. So I will remove that indexing pin plate and then not connecting to the standoff. And of course, I'm driving it to the milling without the indexing. So I made a couple of other small differences, and that also goes for instance, the size of the holes. I make them also in the designs with the scale factor now in them, and as you see here, so I change this to make the fork to connect it later, but I will now use it as is, because it's very slow to do any edits on this design now. So I will break it up and just export these parts and work on them piece by piece. For that I use now the create derive, and I will in this case use a new design, and of course I will select the objects, and that will be only in this case body, and I make a new one. I can place it at origin, that's okay for this way. And now it will work further just in this design, and that goes also for the other parts. So just make a couple of derives, and you see them here coming as a derive. I leave them also as a derive, but then I will work on this further in here. I changed some sizes, and I took out the holes that are here. And for example, I will make the design depending on my parts that I have here laying around, and which I can work on with my limited possibilities. So this will be the stock materials, and I will make it with first a bushing that goes around here and also deep in there that I can connect. And without any indexing possibilities, I will make holes in it to connect that to, but then inside there will be a 20mm or something around, probably 19, through the middle of it, that will connect all the way to the spindle instead of one part here. But of course that one part here will be also using to slide the other part around. So I just made a sketch on top of this plate in this direction, and as you can see now the size here will be 110, so that is possible to work on my lathe. And here the diameter is, let's click automatically, 42.6 something after this scaling, of course. And it's not practical for me, so I will go to a size that I will have. But first I will make here the circle with the diameter. I can put it already in, no problem. Say 50, just to fill this whole space up. and I will do that in extrude, and then I will of course here make the new holes in to just have it working out better. So for the sizes, I first will collect my sizes of materials now. So looking at the materials which I have available and what I can work on, I decided to use steel rod with, so that's not rod, okay, with 30 outer, 20 inner diameter, and I have a rod that is 20 inner diameter, and that will fit inside of my spindle. So this will be the dimensions, and then I will later make an adapter on the top on which I will be able to screw this plate together with the how do you call it, pipe. Pipe it is, a rod with a hole is a pipe. So on this pipe on top, so that it will be connected and all the way to this axle that will be inside. So it will be a strong fit and will be really fitting and be straight as fast as possible, at least. So first I will close the whole hole, just all the way up, and I will just go from here to objects, and that will be here, and then a join. So this plate is now full plate, and then for this plate the only hole that will be needed is of course this inner hole, which will go in both directions, at least also to here, and then a cut. So now I have this whole plate with this size already ready, and then I will define from the other side, from this side, then where will be the connecting places. So now we'll be making a sketch. Let's see if I can find, yes, here on the outside, yes, and that will be also a circle. I can use the original plate, of course, and that will be part of 50 aluminium, which will be going, alright, as you see I took the wrong place of the sketch, but that is no problem for this. And that will be having mounting holes, so I will design one mounting hole and then a couple of them. I have to make this under the drill, and this is a drill holder because I don't have a drill press and I cannot go deep enough in, I think, what I use for a mill at this time, so I will probably use this plate. Maybe I can do it on the mill. I have to look for that if possible to be accurate as possible, to have the holes going inside, and of course I have to make it going outside of there too. So I have now made the design. This is 6.2 hole and this will be 48, because I know that I can then just make it round, really round, with the real size I will need. So I will go deep in making, it will be a bore, of course, on the outside, while I have to keep the piece on with the inside already. So it will be always a bit tricky machining for me. So I will make it 15 millimeters deep. That will be more than enough. 10 millimeters deep is more than enough already. So that will go in there. And I will make the holder accordingly. Okay, I will. So also I will extrude again. That is the outside piece, which I will go extrude on two sides. So this direction will be 10 as before, and the other direction will be 15, I think best, because I will have to tap the holes in there. So that will be 15 millimeters, and that will of course not be a joint, but a new body. I could make a new component as well. I selected the hole as well. Okay. And then I have to cut the holes in both. And that I will do. This can be a full hole, no problem with that. So I can go. I just go in symmetric 100, which is always enough in both cases. So I will have this hole there. Both parts. And I can do a chamfer, and then I will make it go around in 4 places, because that is easier to measure and to put on. And it will be just M6 bolts that screw in, and of course it will be having threads in there, and just bolts on top here. And between them I will make the other holes to screw in the holders for the axle. So to make the design, I have here the line, and then I will construct a plane on that. On that plane. And then when it's a bit problematic with the recording thing, that should be there. And now I should be able to just design the holes in there. So as you see, I have just made on that plane, I will make this whole location of the hole, so 8 from the start, and then 6.2 diameter. That will be the holes I will going to make. And then of course I will just go very long. Doesn't matter because there's nothing else in the way. I can make a little fillet for the start. Doesn't matter what it will be at the end. So normally it will be fillet, of course. It's just to make it visual and easier for the screwing, because this will not be done in the CNC. And then I can start creating the threads, and I just can make that work. So after creating the thread, now I have to make this. Let's see, this is hard to see because the video editor is on top of it. Oh, record problem. Okay, I create the pattern, figure pattern. I can make it. And of course, I will use the features, and that is this one, this one, this one, and this one, I guess. Axis select, that hard. And because I cannot use the indexer at the moment, I just make it 4. So I will have 4 in one direction and 4 bolts in the other direction to hold it all together. So this will be the holder, and this is then the index plate. It's just the tapped holes, the holes for the indexing in there.
Voor meer video's over 3D printen en de gerelateerde onderwerpen zoals het slijpen, milling, alle CNC en dergelijke, ga naar www.patreon.com/elvinhaak. En hier zijn meer van mijn video's te vinden dan op YouTube, minder beperkingen en vaak ook maanden eerder ter beschikking voor de wat langere series. Ook zijn hier diverse gerelateerde downloads beschikbaar die bij de video's horen. Je kan ook kijken op Facebook, 3D Printer Beginners Nederland, Nix Reality wel aan het Octoprint, etc. Dat is een aparte pagina. Mijn homepage is www.elfiets.nl/3dprint, YouTube @el3dprint. En als je deze video's interessant en of leuk vindt, klik je op het duimpje en abonneer je of volg op de hoogte gehouden worden. Je kan altijd nog vragen stellen via de Facebookpagina of dus aan de onderkant van deze video's. Tot de volgende video.